Hello, and welcome to Who Would Pay for That Feature, adding application analytics to your Windows Phone 7 apps. My name is David Peschel. I'm a developer at Preemptive Solutions. And I want to start off today by asking a question or two. How many of you have used analytics of any sort on your applications, on your websites? Who hasn't added a little bit of JavaScript to their web template to see who's going to what pages? We're here today to talk about a little bit of how that works on the phone. So has anybody used runtime intelligence for the phone, runtime intelligence service for the phone? OK, so a couple. We're going to be going into some detail and doing an example with that. So there will be a bit of a deep dive, but I'm going to keep most of it a little bit at a higher level before I dig in. So what I want you to walk away with today is sort of an understanding of what analytics on the phone really entails, what questions can be answered by analytics on the phone, because it's sort of a lot more than on the web, and we'll get to that, and how you can actually go about implementing that and answering those questions on your apps. So the worldview of analytics present day is split a little bit between application analytics and web analytics. And both have their pros and cons. With application analytics, I'm speaking of things like Microsoft's Customer Experience Improvement Program. When you use Blend for the first time, you get the do you want to opt into analytics? But it's a bit of a luxury because not everybody's able to implement that type of a system. It's costly. It takes some time. But you can gather really deep data. They can get exception reports. They can get user data, all of those things. And on the complete sort of polar opposite end, we have web analytics, which is typically just gathering page views and downloads. You can get more, but it's sort of surface level usually. But coming from the web, we get a benefit that is that everybody expects analytics on the web. You wouldn't put out a production website without having some sort of analytics to know which pages people were going to. And that type of analytics is really targeted towards marketing, your marketing departments. Applications really targeted towards developers and designers and marketing. And the web with Windows Phone, in particular on the mobile device, steals a couple of the best things from both. We have somewhat of an expectation now because it's so similar to web. I saw a tweet yesterday after the Windows Phone 7 boot camp about how pages on the phone look and act more like web pages than applications. And so it's the same sort of expectation of analytics, but we get a lot deeper data because the engine, the CLR, is backing what we're doing. So the first thing we want to do is figure out what our requirements are for analytics. This isn't just dropping into place a little bit of JavaScript in a template, and that's the end of it. Analytics gathering is a proper part of your development cycle. There's requirements, implementation, getting the results of that implementation and feeding it back around and doing that cycle. And I'm actually going to step through these various dimensions of application analytics requirements, sort of from most basic and simple down to the most complex. And the first one is basic application adoption and usage. How many people are downloading your app? How many people have transitioned from trial mode to purchased? Are the same people using it every week? Or are you getting new adopters? Is it tailing off over time? So we can answer some of those questions. Additionally, we can answer questions about the user experience. So knowing that a feature has happened on the phone is one thing. So somebody's clicked a button or navigated to a page. But sequencing those events is another. Personally, I have a hard time understanding this elevator interface. And I would probably get onto the elevator and spend a couple minutes before I picked a button. And so knowing how much time has elapsed between events can let you know how confused your users are, how much time they spend on your settings tab is a negative, not a positive correlation. And so we can answer those sorts of questions. Improving the quality of your application, which has a bunch of things. We can measure performance. We can measure disk usage, memory usage, even get exception reports to help you improve the quality of your application. Which sort of leads to support. So depending on the type of application that you build, support could mean a lot of things. Support could mean knowing that exceptions are happening on the new release of Windows Phone that weren't happening on the previous release, and patching that and fixing it quickly. That could be one version of support. Or you could have let's say, an insurance application where the user logs in and it ties to backend data in CRM. Then if that person experiences a problem, you could actually do real support, knowing what their serial number is and like full traditional support department support. So anywhere from the basic one guy building an app by himself to a whole team building an app, we can gather information that can help us support. User profiling is the next thing. It's probably the most complex, but we can actually figure out how our users are, where they're coming from. So that could include demographics information, or it could include just their behaviors and their tendencies. And just like, as an example, let's consider an app that does news feeds. So we've got an app that shows common, interesting RSS feeds, and maybe some of it's like world news, maybe some of it is sports and celebrity news, and you think that people are going to be most interested in news because you're a developer and that's what interests you, and then you come to find out later that everybody cares about the gossip. And so it could actually mean user preferences and their desires and the way that they are in their interaction with your app. Combining all these things can help you target your application, target your updates, target your advertisements, target everything to help you be viewed better in the marketplace, get more application sales, more usage if you're doing ad-based revenue. And that's sort of the list of things that are the mostly distinct groups of analytics that can be gathered from a high level. And we could talk about this all day, about the various types of questions we can answer, but it doesn't really mean much until we make it practical. So how does this fit into your design paradigm? There's 3 basic steps, as you see on the left. The instrumentation process of actually deciding what you want in your application to be measured and actually changing your application to measure those things. There's data collection, which is running the app once you've deployed it to the marketplace or even once you've deployed it locally and gathering those analytics. And finally, reporting on those. And we're going to walk through all of these steps today, but I wanted to give us sort of a high level of where we were headed with this. With that, the first example app I want to use is actually Telerik's Windows Phone 7 Controls sample application. And fantastic app. I love their controls. And this app surfaces the controls, lets you favorite them, do all sorts of things. And it's a fantastic example. And we're going to instrument this together a little bit today. But before we jump into instrumenting it, because we can't just copy-paste some JavaScript and get analytics, we need to remember to ask ourselves, which of these are we interested in? We may only want to know about adoption, right? So the simplest thing to do would be to measure adoption, and that's it. But maybe we actually care all the way down to user profiling. I can't answer that question. They could answer that question. You can answer that question for your app. But we're going to go ahead and dig in and start to gather some analytics on this app. So the tool that we use for this is called Dotfuscator. It is Dotfuscator and runtime intelligence service for Windows Phone. And it's offered for free from Microsoft, thanks to the Microsoft team. And it's used to add the analytics to your application. So at this point, we've already decided the types of analytics that we want to add to our app. And I'm going to show you the basic setup, and then we'll pick a feature that we want to instrument together and go through that process step by step. So the basic setup, though, is the same no matter what your application is. So that first step of measuring adoption is what I'm going to start with, and that applies to your app. You can follow these steps today and have basic usage measurement right off the bat. So the first thing we do is make sure that we add our Zap to the Input tab. The Zap contains some assemblies that are in the application, but there's also maybe third-party assemblies like the Microsoft Phone DLL that we don't want to touch. Maybe they're signed. Maybe we don't want to mess with them in any way. So those get added to package artifacts. And we see down in the package artifacts, we've got the Windows Phone Controls DLL and some others. And it's important to add those to make sure that everything works after this process. So the only thing left up in our main Zap package should be our input assemblies that we actually own and have the right to instrument. By default, on the Settings tab, everything is already configured for you for analytics. And that's not to say that analytics will be added to your app by default. You have to take action to add it to your app. We're not doing any sort of spyware or anything. But by default, it is ready to go. All you have to do is go configure your analytics. So I'm going to jump over. I've changed nothing here except adding my input. And I jump to the Instrumentation tab. And this is where we define where in the assembly we want to gather analytics. And so from the high level, just tracking usage, we right-click our assembly, our main assembly, and say Add Attribute, and choose Business and Application Attribute. And these attributes are used to define your data with respect to all other companies and all other applications within your company that are using this service. So you might be from a company that has 12 different apps. You would use the same business attribute on all of your applications, but various application attributes. It's just a way of partitioning data. The business attribute takes a GUID to uniquely identify you, and that GUID is provided by Preemptive and Microsoft for you whenever you begin using this. The company name is optional, but it's used a couple of cases, which I'll show. And the application attribute also has a GUID, which you can specify by clicking the ellipsis button to the right. So I can actually change my GUID. And the name and version and application type are optional. I have a couple of those in there, but we don't need them. And so by just doing that, we're now partitioning our data. So our data is going to be viewable by us when we look at reports, and it's broken up between our applications. So we're talking about measuring first basic application usage and adoption. So we need to be able to know that an application run has happened. So it's up to you as the developer or the designer to know where the entry points and exit points of your application are. Luckily on the phone, it's pretty consistent, especially for Silverlight. We will dig into our, excuse me for a second, dig into our app class. And these methods will look familiar. Application activated and launching are sort of the two entry points, depending on whether you're starting a new or coming back from tombstoning. And deactivated and closing are the two closing methods. And we need to specify that those are the entry and exit points of our application. So on the activated and launching methods, we add a setup attribute saying this is the beginning of our application run. It's just a right-click, add attribute, setup attribute. The setup attribute is, it marks the beginning of your application, and it also sort of is a pivot point on the level of identity and privacy care that you want to take with your application. So I could spend another hour talking about privacy concerns on the phone and personally identifiable information laws varying by state and contract with phone companies and all that. But this is where a lot of that is controlled. So the first thing I want to point out is that we're choosing our endpoint. So where is the data going to go? By default, on the free version, it sends to the Windows Phone 7 data endpoint offered by Preemptive. And you can change that to your own endpoint. You can build your own endpoint. There's a Coplex starter kit that I'll link to at the end. If you want to own your data, it doesn't need to be hosted anywhere. You can have your own endpoint and own that data. So that's one aspect of privacy. Another aspect is the data integrity over the wire. So if people are sniffing packets, the ability to use or not use SSL is also configurable here. And finally, an actual opt-in choice can be provided to the user using this opt-in source. And this is the first of a number of ways where this analytics can really interact with your application. So how this works, and I'll show an example of something similar to this once I get to the actual coding part of the demo, is you specify a Boolean value at runtime, any Boolean value coming from a field or a method return or a property. And depending on that Boolean value, it'll either send analytics or not. So you could actually surface a checkbox to say, do you want to provide feedback? You wouldn't see an application on the desktop provided by a company of the likes of Microsoft or something like that taking analytics without asking you for explicit opt-in. And so this is to provide that option. So it's on the phone, it's a little bit up to you to surface that option, but if you get a Boolean value at runtime, you can provide to the engine, and then it will choose whether to send the data or not. And so if you're working on a, like I said before, like an insurance app, these questions are very important. You should know precisely what you're doing and take advantage of these risk mitigation features. So we've declared where the beginning of our application run is, and we also have to declare where the end is. Like I said, it's on closing and deactivated, and we add a teardown attribute to both of those. So it's saying this is the end of an application run. And again, we've wrapped both of the exit points of the application. And with just those attributes, so the attributes that we used to partition our data, and these attributes to say this is the beginning of an app run, this is the end of an app run, we're now able to measure who's using our application, how often, and whether people are returning to the app or whether they're using it for a week and running away. The way that that's sort of done from this is there's a bunch of things that you get for free just by adding this. Unique user counts are done by this for free. Depending on your capabilities and your WM app manifest, it will either use a part of the ANID that is guaranteed to be consistent but unique between users, or if you don't have that particular capability specified, then we'll create a GUID for you at the first run and then use that from time to time. So that's how it sort of tracks unique users over time without you having to specify any sort of serial number. I mentioned earlier that you could have a serial number, and that's specifiable in the setup attribute as well. But that's what we get just from adding these features. So I build. And it's worth taking a look at the file system. And this bin debug directory is where the zap file was built. I've been building from Visual Studio. Obviously, you'd have a release build. And then that's also where our configuration file lives. And once you've built, we produce another zap file in the .obfuscated subdirectory, which is our instrumented application, which I will deploy to the phone. So nothing up my sleeve. This was built just now. So I will deploy that. And there we go. And so I just started the application. We hit application launching. It sent the fact that the application started to the server, and now this has been counted as an app run. Whenever I stop the app, no matter how I stop it, counts as the end of the app. We know how long they spent in the app, and we know that this particular user has used the app one time. Now, let's take a look in their app a little bit deeper. I'm going to look at the data-bound list box. Now, they have a bunch of various examples of data-bound list boxes. One of them actually calls out to a web service, to eBay. So it started the web call, and it's finished, and our data is loaded. So we want to know, first of all, that this feature has been used, that somebody has actually gone to this page, that the call to the web service has happened, and that the response has come back. That's a starting point. Maybe we want to know how long that took. Maybe there's some other things we want to know, like how many results were returned. Let's actually go ahead and instrument that together and gather some of that type of data. So I know because I'm the developer, or if I'm the designer, I know because I've talked to the developer that this particular control is specified under data-bound list box web service. So here I can see the contents of my web service class, all the methods and properties. Now, I look at the code, and I see load data is the method that gets called right whenever that call first goes out to the web service. So I want to know that has happened. That is a feature to me. It's important. I want to measure that. I want to know how many times people are using this. So I come here, I find the method load data. I right-click, add attribute, and choose feature attribute. So feature attributes are a way of tracking feature usage. The basic feature attribute by default is just a tick type, which means this has happened, as opposed to a duration, which we'll do. And all I have to do is give it a name. So web service called. OK. So I save that, build. All right, we have a new built Zap file that is going to collect information about this feature's usage. I'm going to go ahead and deploy that. But this time, I'm going to bring up Fiddler. And I've got Fiddler tied into the phone. It doesn't work automatically. You have to set up Fiddler to be a proxy for the phone VM. There's articles online about how to do that. And I also have Fiddler targeted at the phone, so I won't get any noise, hopefully. I'm going to go ahead and run. So we see already that some data went. That's probably the setup, the fact that the application's been run. I'm going to dig into the list box. I'm going to come over. The data that just got sent was another feature that I had instrumented when they navigate to the app. But now, when I navigate to web service, okay, you see it's calling eBay. It's getting a whole bunch of stuff. And between when it called eBay and when it got the results, I actually got a call out here to the endpoint that the data had been sent. And I can actually look in here and go down to, there's a whole bunch of XML, but I can look at the particular message that got sent. And I see that it's a feature message. It's a tick. And it is called web service called, which is what I just added. So this will be reported on the portal end, which we'll see in a little bit. If you wrote your own endpoint, you would immediately know that this has happened, if that's what you want. And so that's basic feature usage using runtime intelligence. Like I said, maybe we want to know more than just whether or not the features happened. Maybe we want to know how long that took. So I'm going to go back and actually update the application in here. And this is another one of those cases where I sort of need a little bit of insight into the app, but any developer could probably tell me how to measure the end of this. And the end is really when onItemsLoaded gets called. And it's sort of the handler that's tied to load completed. And so I come back to Obfuscator. I find my onItemsLoaded method, and I add another feature attribute. I have to name it the same as my other one so that they can sort of correlate as a duration on the portal side. And I had named that web service called. But now I need to specify that the one that is attached to load data is actually the start, and the one that's attached to onItemsLoaded is the stop. So now I've got both of those. I can build. I'm not going to deploy and show you the data. You will see the data, but I'm not going to deploy particularly for this one. The durations are actually calculated on the portal side. In the event that a feature was incomplete, we don't want to be trying to correlate starts and stops necessarily on the client. It makes a little more sense to do the durations on the server side. But all the timestamps are taken from the client, so it all works out correctly. So while I'm in here, let's add one other thing. And I want to know at the point at which my items are loaded, what my ecosystem looks like on the phone. I want to know how much memory I'm using. I want to know how much memory is available. So I'm going to go ahead, add a performance probe on the onItemsLoaded method. So when this whenever this method gets called, a feature attribute will go to say that the feature has completed. We've reached the end of the feature. And also, it will take a snapshot of the memory usage on the phone right at that time. So I'll go ahead and build this again. This time I'm going to deploy. Clear out some of my Fiddler data. Going to go back here and come over to web service again. So eBay call, eBay results, and analytics data. So this time, let's go. First, we have a feature message. This feature message is actually probably the navigation to the, so this is from the navigation to the data-bound list box in the first place that was previously instrumented. This is also that. This one is finally our web service called, and this is the start, the feature start. So this is the beginning of the web service call. And then next, we get a performance probe, which is the sort of ecosystem on the phone at the time. And we can see we're using 0% CPU at the point at which the results come back. And our process is using about 46 megs of memory. You can add these performance probes to the beginning and the end of a method and name those different things. So you can see sort of how much memory you ate during the execution of a single method, or you can put them on different methods. The options are sort of endless there. And then we see the feature message that tells me that my feature has stopped. So the duration between the stop and the start will be reported as how long it took for the data for the web service call. And you can imagine if instead of calling eBay, we were calling your web service that you had deployed to the cloud, you could track sort of that from both sides. And this talk's really about Windows Phone, but there's a reality that most phone apps, not most, but some phone apps, talk to web services. And so you can get sort of get at both sides of it. I mentioned earlier that one of the key benefits on the slide where I talked about mobile analytics being the combination of sort of desktop and web was the deep data. And so we're capturing sort of events that are happening, button clicks, returns, asynchronous calls, return calls. But we want to get a little bit deeper data. So we know how long this call is taking, but let's try to correlate that with the type of network connection that the phone has at the time that the call is made. So maybe it takes 2 seconds on my laptop because it's actually using the wired connection. But if somebody's on Edge, it takes 10 seconds. And so that's really important to know like what percentage of your users are on which types of platforms and how long the performance is taking for them to know what their experience is like. And maybe that's something that can't be tested very easily by a small test team, but could be tested using this. So I'm going to jump back into Visual Studio. And at the point of on items loaded is when I want to know really what my network connection is. So I've actually already got a little bit of code in a snippet. Well, not a snippet, but over here. And what we have is a method that's been added called network connection custom data. And what it does is it returns a dictionary of string to string where the key is network connection, and the value is the network interface string that represents the current network connection. We can gather any string dictionary that's available at runtime. This is just one tiny little thing we could gather. I'm actually going to go ahead and add one other thing to this. Maybe I also want to know how many results there were, because that's another thing that could affect sort of how long the web service call takes. We'll call that number of results. And this probably isn't the best way to do this, but I'm going to grab eBay items collection.count because that's been populated by the previous method. So I'm going to go ahead and build that. So now I've got this new method that returns a dictionary. It's not called anywhere. It just sort of sits there. There's no static call to it in your source. But what we do is in .fuscator, and it's telling me that the package has changed, so I'm going to go ahead and update. In .fuscator now, we specify the point in the application at which we want that string dictionary to be reported to us. So for us, it's on the onItemsLoaded method, which I got to find again here. On items loaded. And we've already got a couple things here. We've got our feature and performance. And so on our feature attribute, we have extended key, a suite of extended key options available to us. So for our case, we just wrote a method that returns the dictionary of string. So I'm going to choose method. Remember, this is any dictionary string. So it could be in a field. It could be the return from a property. It could be anything. For our case, it's a method. The name of our method is network connection custom data. And that method is part of the, it's part of the web service class. And it's the developer's responsibility to know that this call can be made. I mean, we'll tell you if the accessibility is bad, but what actually happens is a call gets injected into the method. And so if onItemsLoaded was static, but my network connection report was instance method, the call wouldn't work. And so you got to sort of know that it's accessible at runtime. So I'm going to rebuild. And so we're combining a couple things. We're combining the feature stop, the fact that the feature is ended, with this extra sort of custom data. And now I'm going to look at my build output. And I see web service called type stop. If I had done something wrong with my extended key, it would warn me here and let me know so that I could go back and fix it. So we know that we've done this correctly now. So I'm going to deploy yet again. Let me clear out my fiddler first. Go ahead and jump right in. Let's go back to web service. All right, call out, results, analytics. So I'm going to dig back in here again. Our first message is just the fact that we navigated to it again. Then we have our feature start, which we didn't change our feature start, so we're going to pass that. Performance probe, we also did not change. And here we have our feature stop. So this time, we have a node called extended information. And we see that our network connection type was actually wireless 8211. And our number of results was 50. So you can see all of that here in the XML. You don't have to do all of your reporting through looking at the XML, of course. There's reports. But this is just a quick way you can see whether or not you've instrumented the app to get your analytics correctly. So string dictionaries turn into this type of data, which turn into custom reports based on runtime data of the application. Let me jump back to Obfuscator. One thing I'll point out is that in this particular case, the user has the option to cancel the web service call. And so if they cancel the web service call, we don't really want that shorter duration to affect our statistics, right? We want to know how long the actual web service call is taking, not how long it took them to click cancel. So the way it's set up right now is that when onItemsLoaded is called, that's when it's going to report the stop. And it reports the stop at the end of the method, but the end of the method really means anytime there's a return. So even if it was canceled, it reports that the end of the feature has happened, reports that duration, and then it skews your data. So this is a little bit of an advanced technique to really get precise data depending on the way that your app's set up. So in this case, I'm actually going to come down to the point in the method where I'm completely positive that my data has been returned correctly. So here I'm completely sure. So I'm going to change this to report web service call completed successfully. And that's probably the longest method name that I've ever typed. But I will now actually go ahead and create that method. Let's make it void, and it's not going to do anything. So now this method gets called precisely the times whenever the web service call completes successfully and the user didn't cancel. So what I'm going to do now is come back over here. I've got this new method I have to build. And then once I build, I can refresh in Obfuscator. And now I've got a new method, which is where I really want my feature to stop, because I'm positive that everything's been done correctly. So I'm going to go ahead and move the stop over to that method. right from here over to here. I'm going to build. Oops, I'm going to build. OK, so now we've moved sort of where the stop was to this method that only gets called when we're sure that the data has been received. If the user hits the cancel, there's sort of this floating start without a stop. And that'll report as an incomplete feature, and that's OK. It won't affect the timings. It won't affect the average timings. And we get precisely the measurements we want. So you can make solid decisions about your application implementation and your user interface without having any sort of skewed data. And again, we didn't need to do that. Our data probably would have been pretty good without that. But if you're a stickler for data like I am, then things like this might be useful. OK. One other thing I'm going to show real quick. This particular app already has exception handling built in. Telerik built it in themselves. We can add our own on top of that. Or for your app, which probably doesn't have your own homegrown exception reporting technology, we just go to our main assembly, again, where we added our business and application attribute, and we add another assembly level attribute called the exception track attribute. By default, this is going to pick up globally unhandled exceptions. And it's, by default, going to go ahead and send the report. This works perfectly fine in Silverlight. It'll work right out of the box. I've used this myself a couple times to catch like phantom exceptions happening on my emulator that I couldn't get through a debugging session, and it really works. But we talked earlier about sort of privacy and individual, personally identifiable information. And so we surfaced yet another report info source where you can tell us at runtime whether or not to actually send the report. And just like the opt-in where you have to surface your own checkbox, you can surface your own checkbox, yes or no, whether or not the data should be sent. So just like the overarching privacy for analytics, there's a subset of that for exception reports. By default, no system or any type of that data is collected. It's just the stack trace and like inner stack traces and all the stack trace lines and all that stuff. And so there's not really much PII to be worried about, but there's always the option of sending extended key data like we did earlier. And so there may, for your particular instance, be personally identifiable information. Also surface a privacy policy that can be used by your app at runtime to let them click through to see a privacy policy if that's what you want to do. I don't have a way of making their app throw an exception right now, but you can imagine. And so that's really it from sort of the practical taking our requirements and turning it into an instrumented application. And we've now built this new Zap file, and this is what we'll test internally, what you'll test internally, and what you'll actually submit to the marketplace once you're certain that all the data is coming in correctly and that you've configured it correctly. I should mention, if you have questions, feel free. But I'm going to go ahead and jump back to PowerPoint. And so we've walked through the first three. Well, we've walked through the first two steps, but the third step is the deploying to the marketplace and gathering data. And of course, this data is not really useful unless we can get reports on it, whether they're default reports or our own reports, and use that to inform our design, use it to inform the way that we target our applications. And so that's the next step of this. I'm actually going to use a different application for the reporting side. Mobile Sommelier is an app by VinoMatch, and it's fantastic. It lets you pick what kind of food you want, and it'll show you the types of wines that go well with it. I've actually got Pierre in the audience, so we'll actually show a little bit of the analytics that we gathered from this. I'm not going to show the application, but you should all download it and use it when you go out to dinner tonight and pick a nice wine to go with your steak. So I'm going to go ahead and jump actually over to a live demo of the application analytics portal that's provided for free by Preemptive and Microsoft. Like I said, you can build your own endpoint and you can build your own reports, but this is what's offered out of the box today. So I'm going to go ahead and log in. Go ahead and jump straight to my app overview. Network's slow up here. So when I jump to the application overview, what we'll see is how are applications being used over time, over geography, lots of different ways of partitioning out the data. Having a little bit of trouble here, just 1 second. There we go. OK, so we can see our application usage over time. There's only one application here. If you had multiple applications, you'd see multiple lines. Particularly interesting, you can go down through operating systems and runtimes, top features, some things like that. But we also get sort of a world view of where our app's being used and how often. So this is one of those things, demographic information that can be used to target your app. Maybe you don't think that your app's being used in places where other languages are predominant, but maybe it is. And so maybe localization is more important than you thought. Or maybe having specifically targeted content based on geography is more important than you thought. So knowing that aspect of demographics will help you target features and content within your application. As a quick tangent, the content is king was actually on the board in the keynote this morning, the sort of the live art that was going on. And this session was called Who Would Pay for That Feature? But what are features really? I mean, features are sort of a combination of functionality and content. And so the question really becomes who would pay for the content? And knowing this type of information about your users helps you target your content, not only your features and functionality, but the specific content. So that's the first thing we see. I'm going to go ahead and look at feature usage over time. So now we see a couple more lines. I've got some things going on. I can choose to view more or less. And I can see like actual numbers of how many times people have chosen foods. Particularly interesting is digging in and seeing which foods they're picking in this case. Are people pairing wine with steak, or are they pairing it with asparagus? So typically, not many people pair wine with asparagus. But there are categories that are more liked and less liked, and we can sort of get that here. And we see the number of times that each of these has been used over the last certain period of time, and we can extend that out to a year and see tons of data. But here you see a quick snapshot of the top so many foods that people have chosen wine to go with. And this is out of 96 different options. So, and you get percentages of each, and you can do your own sort of analytics on that. There's an exceptions tab where your exceptions would show up if there were exceptions. System profile gives you that sort of like operating system level data. I'm going to jump over to data extract. So I mentioned you could write your own endpoint and have the data for yourself. Having the data for yourself and being able to write your own reports isn't restricted to people who have the time to go implement the Coplex project. You can pull out the data yourself using a data extract tool. So this will pull out the data in whatever format you want, and you can write your own custom pivots. And we actually did that with this particular application. And I want to show you a little bit of what we were able to find. So I'm going to jump back over. So the graph at the top represents the overall food usage, foods that were chosen by country. And so we're going to zoom in a little bit and look at just France, Germany, and Italy as they relate to just the first few types of food. And a couple patterns emerge. Of course, Italians like antipasto. Nobody else was even remotely interested in that. The French like their caviar. And so you see some expected results. And what really becomes interesting is when you see things that are unexpected. And so there's, for example, who knew that the French like chocolate cake, right? You'd expect You'd expect Germans to like chocolate cake typically, but they're not interested, and I'll leave it to the app creator to figure out why. But another interesting story is Italians like barbecue, and so there's actually a cool story about how Zinfandel actually came to be the wine that it is today. And it's actually grown in California. It originally was sort of a mediocre wine, but over time it became this fantastic wine. And at the point at which it became this fantastic wine, people started asking, well, where did this particular grape come from? And so there was sort of an investigation into that, and it was discovered that it was originally just an average grape in Italy. And it never made fantastic wine in Italy, but for some reason, the soil in California, and you can talk to wine experts about this, but it became eventually, over time, a fantastic grape, fantastic wine. And the sort of joke is, how do you sell them their mediocre grape back to them in the form of Zinfandel? And it turns out that actually pairs quite well with barbecue. And so to take advantage of that little coincidence is sort of like selling ice to Eskimos. But it's a little anecdote if you know a little bit about wine. And that's the type of like runtime, deep data you can get. And of course, there's no default report in the world that could give you this type of information with regard to your application. There's lots of default reports we could give, but if you want like really specific information like this, it's sort of up to you as the app developer to know your domain and know the types of correlations that could be made, and then create pivots like by country or region, and then using custom extended key data in combination with that. Okay, so to summarize, application analytics on the phone really is this fantastic combination of traditional application analytics, where we get deep data, we provide privacy concerns for our users, and web analytics, where it's this thing that's expected to be done all the time, and you get a lot of buy-off into putting the resources into gathering this sort of data, because it can cause you to create great decisions in your app and get more usage and better feedback on your app. From a high level, application analytics on the phone is not just a thing that you add without thinking about it. You need to know your app, you need to know your user base, and you need to know who, in sort of the agile sense, who the customers of your analytics are. I mentioned that the typical customer of web analytics is your marketing team. But the typical customer of application analytics is your developers and your designers and your marketing and your management. And so knowing your app, your user base, your analytics customers helps you decide what your analytics requirements are. Maybe it's only usage and adoption over time. Maybe it's gathering custom data about what foods are being paired with what wines, and so you can hope to target the featured wines better. So that's really up to you and your app. And then those requirements lead you to the implementation. Do you just add those 4 basic attributes to gather runtime, like runs and user counts? Or do you dig into features and custom data and system profile and exception reports? That's all sort of driven by the requirements that we came up with. And finally, that will turn into reports, decisions, and insight that will help you target your app, target your content, target your features, target your advertising, target everything towards getting better reviews, getting more purchases, making more money. There's sort of a missing arrow here that I would like to draw in manually in your heads, which is that will inform your application again and cause changes in your applications, which will cause changes in the requirements. And so this is really a cycle, just like software development is a cycle. If you want to keep improving it, of course, you can just gather basic usage and move on. But I'd encourage you to keep adding and keep getting more and more insight and making better and better decisions. We walked through how to instrument your application from the very basics that apply to everybody's app today. You could go ahead and get started, to digging really into custom data and gathering string dictionaries at runtime. And we showed you how to look at reports in the portal and how to sort of think about making your own reports. I didn't show you how that graph was made, but a basic export to Excel and a pivot, how you can make your own reports. I say mashups there because there's also the potential that you could mash this up with like CRM data. I don't think that's very common on the phone, but there's a potential, like I said, insurance apps earlier are a good example where you might have back-end user data that you could tie together. There's some resources available to you to get started immediately with this. Obfuscator and Runtime Intelligence for Windows Phone 7 is available today at preemptive.com/WP7. It is absolutely free for Windows Phone 7 users, developers, and it comes with sample Silverlight and XNA applications and configurations, all the way down to solution files that include string dictionaries in them that get called from the configs. It's everything we did here and more. I encourage you to take a look at that. There's a couple other resources there, briefly, about getting started and creating an endpoint kit if you want to own your own data. And we're here all week. If you want me to sit with you and help you add analytics to your application, I will absolutely be glad to talk to you and help with that in any way I can. So we have a few minutes remaining for questions. Before I take questions, I want to point out the session code in the corner. If you care to fill out the evaluation, the title of this session is quite long, but if you put OPN11, then that will report correctly. And with that, I am happy to take questions.
Yeah, great session, great product. I have about 60 apps published with Phone 7, all instrumented with the.
Wow.
Yeah, and
fantastic.
It's great. It's really great. And I used a lot in trial strategies, figure out what features you're using. But anyway, the question I got was that map, right, that you show. That's the big endorphin rush, right, when you get that and you see all the people loading up your app all over the planet. I was just curious how you do that. I mean, do you do IP address lookup, or is that device, you turn on device tracking for that? Because I know there's no warning message when you download it saying it's being tracked.
Yeah, so we do not, in any circumstance, add capabilities to your application. So we won't add the geolocation capability automatically. Even if you have the geolocation capability, we won't use it because it's expensive, it's a drain on the battery that we don't want to impose on you. And so what ends up happening is the IP address of either where the carrier, the local hub is, or if you're on the wireless, it just grabs that, of course. So for actual 3G data, it's a little bit rough. It's not precise, of course, but it's to the basically the tower or regional location. So it's approximate but pretty accurate.
Cool. Thanks.
Yep. Thank you.
Follow-up to that, is that then how you got the geography in the report of the cake? Okay. Analytic capture, if the phone's not connected to a network, does it buffer that?
Yeah, fantastic. So let me get to that. So one of the things we saw actually was in Fiddler, it was a bunch of features were happening, but it was only making one web service call. I don't know if you noticed that. I was sort of closing up messages one by one, but it was all part of one envelope that went. And so first, I have a feeling this is going to be a follow-up question. So first, we batch and send to make sure that we're not wasting battery. At the point at which we've batched and we're ready to send that group of messages, we know whether or not there's a network connection. And so if the network connection is there, we'll send it. If it is not there, we will, by default, store it into isolated storage for you. If there's an attribute, there's a property on the setup attribute that you can set to say don't use isolated storage. If you want to tell us don't, just if there's no network, just drop the messages, then we'll do that. We're smart about our isolated storage usage. If you instrument every single method and tons and tons of data, we'll start deleting the old one out of isolated storage. So we're not gonna hurt your app really in that regard. And yes, things will be stored offline. There's actually a bit of a funniness. I don't know if anybody here even knows, but there's a networking kind of funny behavior on Silverlight on the phone where during shutdown you can't actually send messages. So that's the first example is we store the teardown message in isolated storage to be sent the next time. So we do make a lot of use of isolated storage and won't lose your messages.
Thank you.
Yep, thank you.
So I had two quick questions. One is, I missed what version of Obfuscator you were using there. Is that the full version?
I was using the free Windows Phone 7 version, which has all of the functionality of the full edition. And so people might have heard of Community Edition, Obfuscator Community Edition. This is not that. It's a separate SKU that was built based on the professional SKU. The only limitation really is that it only will accept Windows Phone apps. And it actually has some benefits in that it targets the default settings to Windows Phone users.
Okay, and that was pulled from the Windows Phone tools? Does that get installed with the Windows Phone tools?
It does not get installed with the Windows Phone tools. And for good reason. So the link that I showed the preemptive.com/WP7. You'll fill out a form, and we'll actually use the data that you give us to create an account for you on the portal by default and create your company ID. And so there would have to be really tight integration for that, and it's just not there. So just one form, you'll get the download, you'll get all of your login information and your company ID, and you'll be ready to go.
Okay.
But you actually have to download it from a separate link.
Gotcha.
Yes.
Okay, thanks.
Thank you.
We've already talked about buffering messages and that sort of thing, but do you have the concept of, okay, don't send messages any more often than, say, once a minute or once every 2 minutes?
Sure. Well, no, I'm saying sure, I understand your question. The current sending model on the phone, of course, it only tries to send if there's data to send. So if you this is not a profiler. You shouldn't be instrumenting something that's going to happen. Don't instrument your game loop in XNA, please, your update loop. It's just bad for everybody. But it's sort of a little bit static. It's set to every so often right now, but it's infrequent enough that it's not really going to kill your battery. I would love to see something like you say, but
well,
just
the reason I was asking is our applications it's live video streaming, and so in that scenario, pretty much everybody's looking at the same thing simultaneously if they're looking at the same event.
Sure.
So when there's triggers or markers that might cause an analytic to occur, like a commercial displayed or something,
yep,
everybody's going to get it at once. And so right now we take special care that we don't want 100,000 messages to hit the server simultaneously. So we stagger them out because we don't really need to know immediately when it happened. We just need to know it happened. So we would need to be able to buffer them and then send them later.
Sure, and that's not supported sort of out of the box today, but there's a couple like sort of trick techniques you could use to talk about that.
Somehow?
But so talk to me afterwards, and I'm interested in your use case.
Okay.
And I actually have a comment from.
I just want to say that the data is going to our endpoint, and it's a n-tier sort of staging process. So even if your stuff all sent that, it's all fire and forget, sent us, we would get that flood, and we're scaled to handle that. So your app and your data flow shouldn't be affected at all. So the feature is a great request, and there's lots of reasons to want to do that. But in your particular scenario, it's not. I don't.
So it wouldn't cause a problem anyway.
In your scenario, I don't see that as a problem.
So just for the video, the response was that the flooding of data is going to hit preemptive servers, not their servers. So it's set up to scale for that, and there's not too much to worry about from that perspective.
Just curious about the robustness of the project, and by that I mean like you've got in the project you're saying we're going to instrument these different methods with these attributes. What happens if those methods go away? Developer renames a method. Right.
So this is all happening post-build. So we're not in Visual Studio watching your source code. We can't tell that a refactor has happened. If a method gets renamed, then that particular, whatever instrumentation was on that method will go away. And so if it was just a feature tick or a performance probe, then nothing bad will happen except you'll lose that analytics. If it's a feature stop that has to be correlated to a feature start, then you'll get a .Fuscator build error that tells you you've got a start but not a stop. Please fix that. So it is dependent upon the consistency of the names of things. And there's really just no way that we could know that you've renamed something to something else. And so that's actually another reason why that method I added, that report that something has happened now, that's actually not a bad paradigm to use because then people know not to rename those particular report whatever methods. And so if that's something you're really concerned about, you could sort of adopt that paradigm everywhere for every feature.
But it doesn't, like in the project, move that attribute down or tell you this method's no longer found, so you'll have to
no, you need to know, yes.
Yeah, okay.
Yep.
And then on those, speaking of that method where it's there just for the purposes of instrumentation, won't that generate an FXCOP rule saying empty method that doesn't do anything? Do you just suppress that?
Well, are you running FXCOP on your pre-instrumented or post-instrumented?
Good question.
So if you're running, the question is how this is going to affect FXCOP because you have unused methods. If you're running FXCOP on your assembly post-instrumentation, there is a static call to that method injected. So everything works out nicely. You don't have to worry about weird things. But if you're going to FX cop your input assembly, then of course you're going to get an unused method. But thank you for the question. I've got 8 seconds left according to the timer. So thank you for the questions. I want to thank the Creative Commons people who let me use their photos. Special thanks to both Telerik and VinoMatch for letting us use their applications. And I just want to say thank you for coming. Again, I'm happy to talk about this with any of you. If you have apps, we can sit down and get analytics going for you today. And thank you for attending.